Thank you for tuning in. I'm Frank and I represent Hackspace from Ballarat, Australia. In this video we'll be learning how to make an XY plotter that can scale to effectively infinite size. Links for everything is in the description. First you'll need some required hardware, an Arduino, motor control, stepper motors, pulleys, belts, an adjustable power supply or just any 12 DC and some weights. As for 3D printing you're going to need 2 motor mounts and a gondola. The supplied STL files can be found in our GitHub, which is linked down below. This is the gondola and this is the motor mount, as which you'll need 2. Make sure you get the one with the screw holes. We're not going to show you how to 3D print in this video, but look up some tutorials, it isn't too difficult. Make sure you have a decent infill as the screw holes need to be threaded, and the finished product should look like this. Mount these to a whiteboard and attach belts. At the end of each belt make sure you've got some sort of a weight. In our case we're using fishing sinks, and as you can see the gondola is all set up and attached to the belts, with the servo motor being routed around and cable managed to make sure nothing gets in the way while it prints, and attached to the CNC Shield, which requires 12 volts from DC power. Here we've just got positive and negative on the left there. As you can see the servo comes in from the left and attaches for power down the bottom, and signal at the top with the 2 motor drivers X and Y to there on the right. Next up you'll need to attach a computer by USB to the Arduino, and follow the link in the description for our GitHub download to get the software you'll need to start drawing polargraphs. We're assuming you have some software already, such as Arduino IDE. Just follow what you see on screen to extract everything from the GitHub files and put them in the correct locations. The software you're seeing is Polargraph Drawing Robot from Mert Arduino, link in the description to get the raw contents. Once you've got that all set up, you're going to need Processing 2.2.1, which is how you actually run the GUI interface for the Polargraph software. It's worth noting that the software attached here is recompiled software that is meant for this CNC Shield. If you're using a more traditional Arduino Motor Shield, you shouldn't have any problems with the original. Again, just follow what's on screen to installing it correctly. Once everything's good to go, it'll detect the serial port you have the Arduino connected to, and hopefully the GUI will load up. Then you'll need to configure your software to match your vPlotter itself. Click on the Setup tab up top, and then look for machine width and height. You'll need millimeters of each. Then you'll need to measure the page width and height, as shown. This is the area in which the plotter will actually print within. Once you've got that working, measure 13 centimeters from the top, and that's going to be your home position for the gondola. Don't forget to click Set Home. Before you can begin printing, make sure you put in a text up. We're just using a whiteboard marker, which slots in like so, and there's screws underneath the gondola that will hold it in place. You can also wrap the texture in some sticky tape for extra support. If you save configuration, you can load it from any other machine, as it's saved directly onto the Arduino. This is handy so you don't have to remeasure things in the future. If you're having any issues so far, just go through the setups and make sure all of these numbers are correct as shown. If anything's out of order, just change it. Don't forget to make sure your serial port is connected down the bottom here, because nothing obviously will work if it's not connected. The Polargraph software offers three main ways of printing. The first is image, second is pixel rendering, and finally vectors. If you want to print an image file, just follow along what you're seeing now. Currently, if the image is too large or too detailed, you may struggle to get it to scan in. The app can crash or freeze, so keep that in mind when you're preparing images. Also, don't forget to set a frame, that's the red border you can see now. Anything within that will be printed, anything without will not. Make sure it's covering the whole image, but you might lose some details. This panel is effectively turning your image into a vector. Mess with the configuration as you can see. Once it's done, hit capture, and you should be able to print. The next method of printing is pixel rendering. This is great for having really high quality, high resolution images, but it can take a very long time to actually print. You'll want to ramp up the detail to really get that effect, but if the detail is too high, the software can crash, or the print head can mess up and really not look so great. The way this works is by printing it with essentially rectangles at an angle, and making them more refined and filled in as the printer goes along for darker colors, and more space between them for lighter colors. Mess with the configuration until you find something you like. When you're done, just hit print. And don't forget to unpause the queue on the right. The final method for printing is also considered the best. Using a vector image, something like an SVG file, can have the greatest effect for printing, as it's very easy for the program to turn a vector image into G-code that can be printed in a very smooth line fashion. This is the quickest way to put something onto paper and has a very low failure rate. Thank you for watching. If you have any questions, feel free to comment down below and we'll get back to you if we can. Take care.